And it's a new day. Welcome back. Yesterday we fought through practically everything from this point upwards here. Going through everything and getting the understanding of what the code actually does. While it doesn't seem like a lot when thinking about it right now, it took a while, like 2 hours or something like that. But we still have these functions down here, as well as this one, and then the argument parsing as well as the main function here that I forgot about. And but this seems to mostly be for calling the various functions. Yes. I was hoping to go live a bit earlier today, but it's practically the same time as yesterday. That's just life for you. I will just have to hope for earlier streams going forward. Maybe trying for 5 minutes earlier each day or something like that, until I'm at a time that I'm more comfortable with. But yeah. So the stream will probably be a bit shorter today as well due to that, but who knows? Maybe I'll forget the time and just blaze through everything here. One can hope. Anyways, to throw back to what we did yesterday. The last thing was the train BPE function. And BPE stood for bytes something. I can't for the life of me remember what the acronym actually stood for, but something bytes. It's almost embarrassing to have to go back here and look it up again, since this is the third time. But I want to know. It should be here, yes. Byte pair encoding, that's right. I need to mentally connect the P with pair instead of per. That's what's confusing me all the time. Byte pair encoding. Okay. So to go back to this one, there's no point in going through everything a third time. So let's just move on to the next function here, which is the apply merges function. Tokens parameter here, which is a list of strings. Merges, which is a list of tuples, and I actually pronounced that correctly for once instead of saying tuple. And let's say fixed list. Or how do we say it? A constant list, maybe? Whatever. And we want to return a list of strings. Apply merges in the learned order. Each pass replaces all occurrences of that pair. For a B in merges, I suppose that means that we automatically grab the values of the tuple and put them into A and B string variables here, and we loop through all the list items in merges. for all the tuples in merges. And we start with an iterable of 0, and we set a merged variable, a new variable here, a local variable, as I think you'll call them, since they only exist within this section of code here. Or maybe, I'm not entirely sure actually if Python even has like local or what's the opposite word of local? Public, I think. Anyways, I don't actually know if Python has like a local and public variable distinction. I suppose the easiest way to check that is simply to, let's do it here. Let's try using the variable merged, and it doesn't exist here. We have merged sequence, which we set here. So I suppose the variables are they are local to the function, not to the loops and stuff like that, but to the function. I suppose. Can I use I? Would it say undefined name? I'm not entirely sure about this now, but it seems like the variables are local to the function in general. Anyways, that's segue out of the way. We create a local variable called merged. I'm just gonna say local, since that's what I'm that is what I'm familiar with. And then we set a out variable, or we initialize the out variable. No, we set an initialized out variable as a list of strings, and then we loop, should I say, while the iterable I is less than the length of the tokens list. And if I is less than the tokens length -1, and the current token is equal to A, and the current token +1 equals B, then we append it to the out list we initialize here. That's empty from the start. And we iterate by 2, so we skip ahead. But what do we actually skip ahead in? We skip ahead in the tokens list by 2 steps, since we appended the 2 to the out. Okay, and otherwise with the else, then we simply append the current token, and we iterate by 1. And then we set the tokens parameter to the out variable before returning tokens. I suppose this is simply to clarify it, because we could likewise just return the out variable instead of like setting tokens to out and then returning tokens. But this makes it a bit clearer, so I'm not like against that. Apply merges in the learned order. Each pass replaces all occurrences of that pair. I don't really see where this is coming into question. I think that's the issue at the moment. I mean, I don't like have the outside context of where this function is being used. So even though I think I understand like on a technical level what this does, I don't understand like the context of why you would do this. So let's just move on, and hopefully I'll understand it later. Then we have the other function called encode with model, and we want to pass on a model parameter. The model parameter we're actually creating here in the train function, and as well as the text as a string. We want to return a list of integers. Text equals prep text, and that's the function where we basically do all the normalizing and stripping of white spaces, I think. No, we don't strip of white spaces. We only do normalize and casefold. And here we do the white space stripping, I think. Or white space replacement. As we pass along the text here. Words to symbol sequences, I should say. Because this returns a list of lists of strings. And yeah, splits and white space, and we prefix by space, which is the constant character here. And then we have the sequences. And the sequences are basically all the words. Or should I say it's all the characters with a space constant marker in the beginning as a list of strings, and all those list of strings are then in a list of their own in the order of where the words actually, or the symbols actually exist in the text. I don't know if I'm explaining it like clearly, but it makes sense in my head. I would hope so, after all the research into this. And then we have the merges variable here we create, and what type of variable does this mean? Simply a list then. A list of tuples. Tuple P. So it creates a list of tuples for every I mean, we have the merges here, which is a list of tuples. I suppose this is just a way to set merges to, or should I say, access the information in the model. Because this is a dictionary, I think. Yes. So it's simply a way to loop through them and add them to the other, to this variable here. So we go through all the keys and values inside the model merges, and we simply create a new tuple with those keys and values for each one, and we call that the variable merges, the local variable merges here. And we then have the vocab, which is vocabulary, but since that's only a string, I think. No? What was the variable type? A list of strings. So since it's a list of strings, we can simply set it like that, because that was the confusing part for me. I mean, I thought we could just like set merges to model and then merges and get like the tuples here, or the list of tuples. But it seems we can't do that for some reason. It might be since tuples are a constant and we can't change their value after we've initialized them, or something like that. It might just be something like a technical limitation that forces us to do it like this. Like this. And anyways, the vocab works to like only set it directly, and then we get a list of strings. If I'm not entirely brain dead, a list of strings, yes. Oops. And then we have this story variable here, which is a... Oh, what was that? The meaning of story. We had ethos and story. Oh, even though we even have the information here, I think. Yes. String / token to ID for story. Ethos is ID to token / string. So this is for the encoding and decoding, I think. And since this is the encode with model function, I suppose we're toc I for I. Toc in enumerable vocab. It's very similar to this here, but not identical. Simply to refresh my memory, I'm gonna just copy and paste it like this, and then what does this do? Break it down for me. Okay, so blah, 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 builds a dictionary that maps each token to a dictionary. Really? Oh yeah, actually a dictionary that maps each token to a unique integer ID based on its position in vocab. Breakdown: enumerate vocab, turns an iterable like into pairs. Okay, that makes sense. But is it really like the value first, or the iterable first, and then the, or should I say the iterable like a key, and then the other part as a value? I is the index, tok is the token. Dict comprehension, tok I for each I tok pair. Create a mapping tok to I. Result. Here we have the value as the integer or ID, whatever, and this as a key instead. Name convention string / token to ID. So it's the story is where we add IDs to the string / tokens. Why it matters? You use story to turn merge tokens into IDs during encode. Order of vocab defines the IDs, so keep vocab's order stable. Order of vocab defines the IDs, okay, yes. Common pitfalls and tips: if vocab is a set, its order is arbitrary. IDs will be unstable. Use an ordered list like your final vocab list instead. If vocab contains duplicates, later ones overwrite earlier ones. Dictionary keys are unique. Okay, make sure vocab is deduplicated. That's why we did all that in the training function, I think, later on. Or was that before? I don't actually remember, but I remember us doing that. And you can choose a different starting ID if you reserve 0 for add. I don't know what that means, but there might be a simple explanation for it. Equivalent long form. We initialize the dictionary and then we loop through. Okay, this makes so much more sense. So the comma here is that we loop through both values that the enumerate spits out. And since this spits out the values as such, we don't actually want those in that order. We want this to be the key and this to be the value, instead of, as now it's like this is the key and this is the value for some reason. That's why we set in the I to the key and tok to the value, and then we set the variable and we switch them around basically. So the token has a ID value instead. And that's simply what this does. I4 I talk in, så talk this is simply another way to set to do this basically. That's all this is, like the in comparison. And then we have this loop here, which is identical to this one here. And that's that. Okay. That does make some sense that you want to switch it around like that. So you have like the keys and the values. Or the values for the keys are the index or IDs. Anyways, then we set a variable called IDs. And we initialize it. And then we loop through all the sequences. And we create a new variable called merged sequence. And that's equals to a list of strings. As we apply mergers in the learned order, each pass replaces all occurrences of that pair. Is this really correct, or is that a typo? It might be a typo. No, it's correct. Okay. Does this mean we simply pass along the sequence in question? Or what? Then we also pass along the merges variable, which is all the merges in the model. How did this function look? It looked like this. This was the function I was confused about the purpose of. Each pass replaces all occurrences of that pair. But why? Let's do this. Break this down for me. I'm also confused about the purpose of the apply merges function. I'm gonna have to declutter this. Start a new session for the next exercise, I think. This conversation is getting very long. I'm probably at that level now that I need to have like a single conversation for each exercise. Because I mean This is like a lot of conversation. Okay, totally, let's unpack this line by line and the function it calls. Okay, watch each piece is sequence, a list of symbols for one word. And yes, sequence colon, a shallow copy of sequence. Copy so we don't mutate the original list while encoding. Okay, this is the first time I'm hearing about this functionality of copying and shallow copy for some reason. My guess is that it means we only pass along the value of sequence and not sequence in itself, but I thought we already did that. I didn't think we actually passed along like the variable in itself, only the value. But maybe I was misinformed. Anyways, it's a safety thing to not mutate the original list while encoding. Merge as the learned, merge rules in order. This is what training discovered as frequent neighbors. Yes. Apply merges and it returns a list of strings. Takes your token list and applies every merge rule in order, turning adjacent pairs like CA into a single token K or CA. It returns a new list of tokens after all the passes. I think I'm beginning to understand this now. If I'm not entirely mistaken, then this is so we can train the model on text and then supply it with new text and then encode that new text using the trained model merges and stuff like that to encode that new text so that the model not understands it, but like creates like the tokens for it. As it says, it's like simply as a way to encode. And I'm speaking about like the whole function here, not apply merges specifically. But it would make sense that you call apply merges to like apply those stuffs, because what's the point otherwise? Anyways, let's move on here. Why we need apply merges? During training, we learn which adjacent pairs to merge and in what order. During encoding, we must replay those merges on new text. So we segment it the same way the trainer did. Okay. That's exactly what apply merges does, deterministically. Think of it as a recipe. Merge all CA into CA everywhere. Then merge all _CA into _CA, then merge all CA and F into CAF, and so on. Order matters, later merges can only happen after earlier ones shape the tokens. This is a little confusing, but I think I understand it. I mean, it would make sense to like prioritize the more common merges. Otherwise, you might like create fragments and stuff like that instead. How apply merges works conceptually. Ooh, interesting. Interesting. Let me just have some coffee. And okay, so we have the function here. This isn't the exact same one, is it? Oh, it's almost the same one. It might only be like the order that's a bit out of whack. No, it's actually... I mean, it's the same principle, but it's like different. Anyways, you can still read the explanation here. Pass 1, CA, pass 2, underscore CA, etc. And we merge the pair once. Otherwise we skip both, non-overlapping. Tokens out, next pass sees the new tokens. Wait, we're still inside the loop here. And oh, it's a way to update like these here. So we set the tokens to the output. And then we go all the way up here again on the next iteration and we go through everything. And then we have the updated tokens here. And then we do it all again. And that makes sense. Non-overlapping merges: when it merges A, B at position I, it jumps by 2, so it won't reuse those symbols again in the same pass. This matches BP behavior or bytes pair encoding behavior. Multiple passes, each merge rule is applied across the whole sequence before moving to the next rule. What is this rule it's speaking of? Tiny step through example. Input tokens. So this is a sequence then. For cafe, merges pass 1, merges CA to... So the sequence becomes this instead. Second pass. And we have this one here, okay, and then then we merge it like that, and pass 3, merge TNF, and then we have cafe, and then okay. Now it's ready to map to IDs with your stoy. Stoy. Is that what we're doing? Yes, in the next step down here. how this differs from the training merge step. Training updates all words in the corpus. Corpus. What's the meaning of the word corpus?
In general, a corpus just means a collection of texts or documents gathered together for some purpose. For example, in linguistics or natural language processing, a corpus is often a big body of text that you analyze to learn about language patterns. So it's basically just a fancy word for a text collection.
Okay, that makes sense. And after picking the current best pair, training updates all words in the corpus after picking the current best pair. Then recounts to pick the next best pair. That's where merge pairing sequences is used. Encoding doesn't recount anything, it just replays the same list of merges on a single token list to reproduce the same segmentation. Wide slice sequence again to avoid side effects. If you did apply merges sequence merges and the function mutated the list in place now or in future refactor, you could accidentally change data the caller still needs. The copy makes the call pure from the caller's perspective. Okay. And let's move on to the next one here. So for token in merge sequence, then we loop through the merge sequence. Oh, so the apply merges only works on a single sequence. That makes sense. And then you have to do it like for each sequence. That's why we had this loop here. But anyways, while we're still on the same sequence in the sequence list, then we also loop through all the tokens in that merge sequence. And if the token exists in the story variable, then we append it to the ID's list of integers here. And we supply the key to return the value. Okay. Otherwise, if it's not in the story or string / token over IDs, fallback, break unknown token into characters. Should be rare if trained well. For CH or character in token. If character in story, then we append it. Or we append the ID. Otherwise, last resort, add a naive unknown mapping by extending vocab at runtime. Kept simple for this exercise. Retrain on broader. I think that's the correct way to spell it. Okay, so we'll raise a value error otherwise in this, or to keep it simple. But in the future I might want to like add a vocab extension at runtime. If that's even possible. But it might be. And then we return the IDs. That's honestly all we'll return is the IDs of the vocabulary. In the order it's... I suppose that makes sense if we're encoding it. So we only have the... Because we have the vocabulary like already locked down, so all we need like is the ID for the words associated with those. Should say the IDs for the words in that vocabulary, in the order that they exist in or present themselves in. So that it's a really interesting way to, like, I suppose it's actually a real way to encode data. And it should create a smaller file than the original text file, I think. Since the tokens can be represented like multiple times by a single character instead of like the whole text. Anyways, this is like kind of blowing my mind because I didn't even like imagine that's like, I didn't imagine that to be the purpose of this function. But it's only now when I reach like the end that it's like clicked for me. And I suppose then decoding here is like the same thing but in reverse. Decode with the model we pass along the model, and the IDs then, which is instead of the text that we pass along to encode. Now we only have the IDs to decode, and we want to return a string. So we set a local variable to the list of strings, that's the vocabulary, and we set the variable tokens to I suppose this is a simple list of strings as well. I mean, vocabulary here has to be a list of strings. Vocab, list of strings. And oh, so then we set the tokens down to the, I should say we loop through all the IDs, and in each loop we sort of like append the vocabulary and that current ID to the token list, which has to be a list of strings. And then we had the text, which we set to nothing.join tokes. And I suppose that's a way to create like a single string out of a list of strings, is my guess. And then convert visible space markers back to real spaces. And simple text.replace with we set it to itself, but with the space marker replaced by the normal white space. And then we strip the edges off as we return it. Probably to remove any white spaces that would otherwise be in at the start of the text. Due to how we always append like a space character to the beginning of each word. And yeah, that actually makes sense to me. It's a tiny function compared to the behemoths above, but I suppose that's progress at least. I'm gonna take a short 5-minute break here, I think, to clear my head a bit, and then we'll move on to the decline section here, and then the main function, which looks a bit dense, but should be easy enough to understand with all the other functions already figured out, somewhat at least. So I'll be back in about 5 minutes. And I'm back. Had some grapes and just lay down for a while. I don't know if that was even 5 minutes or if it was like 3 minutes, but whatever. It helped a bit to clear my mind. I'm feeling like my throat is a bit sore though from all this talking. I'm honestly like speaking more than at any other point in the day while I do this stream, so my voice gets kind of exhausted pretty easily. So I have to parch my not parch my throat, slake my parched throat quite frequently. And just a few minutes, like lay down and let my voice rest, helps a lot. But I can still feel it in my throat that I've been speaking a lot. So let's just move on. So we have the parse args function. This is something we've actually done like 2 or 3 times by now, so it shouldn't be like too difficult to figure out. So we create a argument parser that we call, the program is this script here, and we give it a description, minimal BP, or should I say byte pair encoding tokenizer, train, encode, decode, and then sub we set to add sub parsers. Dest is my guess for destination, and CMD for command line, and required true, and then PT is set to then sub add parser, okay, add PT for P training, like parser training. So we add a parser called train, and a argument, should I say, called train, with a help description of train, a BP model from text. And no, that's not correct. Here we add arguments. We actually call it a add parser. Okay, so we set it to a parser, and then we add arguments to that parser. First one is input help test file to train on, and then we have add argument vocab size, type an integer, default sets to 200, so 200, should I say tokens? What do we call the vocabulary? What do you call like the vocabulary items in an LLM?
So the vocabulary items in a large language model are typically just called tokens. Basically, a token is one piece of the text that the model knows about, and it could be a word, a part of a word, or sometimes even a single character. So when you're dealing with an LLM, you're really working with a whole bunch of tokens as its vocabulary items.
Tokens. Tokens feel like kind of like nebulous to me. I understand what a token is, I think, But there's so many ways like to it seems like there are multiple ways like to have a token, or should I say like there are multiple, it feels like there are multiple use cases for tokens, so it's a bit confusing, like what do you actually call something? Do you call it a token, a symbol, a character, a string, like stuff like that? But I suppose like token is kind of an umbrella term when it comes to like large language models. Or should I say like the not an umbrella term for large language models in general, but like their components. I don't know, I'm rambling. I should rest my voice and stop rambling. And then we have the normalize, and with the boolean values, and same with the lowercase here, case fold, and the argument for -o or $o out default is a JSON output model path. Okay. So if we don't set it to something specific, then this is the name of the output. And the path is probably like the same folder and everything, like in this sandbox folder here. But otherwise you could like change it to something else probably. Or it might only be like the name, I don't know. Yeah, it might actually only be the name of the file. Anyways, then we have the P for encoding, and we add a parser, calling it encode text with a trained model. P add argument, model help path to model JSON. Okay, so then if we say like model, then we should provide a path. And we have no default or anything for that. And then we set a grep grep, perhaps. Grep equals p dot add mutually exclusive group, required true. This doesn't say anything to me. I don't really understand this. And then we add another argument text, inline text to encode. I suppose this is actually like in the console we have to like type the text ourselves. And then we have the file and file to read and encode. And then we have PD for P has to be program. That would make sense. Program training, program encoding, program decoding. And decode IDs with a trained model. An argument model with a path to it, and we have the argument IDs required true, yes, because we have to have something to actually like decode. Oh, that's why we have like this add mutual exclusive group. This means basically that, and with the required true here, like it's the same as this one here, but we have it then for the both of them. And also we can't use like --text and --file. We have to use one of them. That's the add mutual exclusive group part. And this is the only group, probably, as a shortcut. And help comma separated integers. Return p parse args. I can feel my throat like dying a little. But I should be able to get through this last part here. I don't want to like break the stream here. That would be kind of lame. I've already split like just this this knowledge segment of the stream to 2 parts. With the first part being like up to this part here, and then this part today. So yeah, I'm just gonna keep fighting. So we have the main function then that returns nothing, and we set the args variable to parse args, or what we call the function, and argv is the default of none, but it might be arguments if we supply it ourselves. So if args.cmd equals train, if we want to train it, then we set the data variable to path args.input.readText encoding UTF-8. Oh, because we have args.input, and even if we typed it in the terminal, or if we supplied a text in a different way, like in a file, .read text encoding UTF-8 will like pass this along to the data here as a string. And then we have the model, which we call the function train BPE. We supply the data, and we supply the parameter vocab size with the argument for vocab size, as well as do norm and do lower. JSON can't store tuples. Convert merges to lists. Okay. It makes sense that JSON can't store tuples since it's a text file or whatever, and these are supposed to be you shouldn't be able to change tuples. Okay, so model to save. So after we've trained everything, then we go down to here, and we have the variable model to save, and we set it to a dictionary. No, yes, dictionary. And we have 2 asterisks for model, and I don't understand this part here actually with the asterisks. I'll have to ask Rufus. Break this down for me. a new item. Nice. I disappeared. Yeah, there we go. Here's the line decoded. What each piece does. Asterisk model. Dict unpacking copies every key / value from model into a new dictionary. Shallow copy. There we have this expression again. Shallow copy. And merges. This is a list, right? Yeah, a list of override sets. Override / sets the merges key in that new dict to a list of lists. A list of lists for A, B in model merges. So A and B in model merges becomes a list instead of the tuples, because it's a tuple, I think, if I remember correctly, normally. Wait, where do we get this information from again? After we train it, here is merges list of tuples, yeah. And that's why we set it to a list of lists. If there is a learn merge pairs, each merge pairs, each pair is a 2-item sequence, usually a tuple. A list is a list comprehension that turns each pair into a plain Python list. For example, oh, it's the brackets, that's different. And this is a list then, and this is a tuple, maybe? Wrapping it all in curly brackets, produce a new dictionary. It's the same as model, except merges is now list of lists. Okay, so it's... Wait. Everything is the same in the dictionary, except for the key merges that we instead set to a list of lists of itself, of the values of itself that were tuples. Okay, so it's just another way to like copy everything except merges. As it says here, copies every key value, overrides. Okay. Why we do with JSON friendliness? JSON has arrays, not Python tuples. Python's JSON.dumps will serialize tuples as arrays anyways, but when you load them back, you'll get lists. Making them list explicitly keeps save/load symmetric and obvious. No mutation. We don't modify the original model. We build model to save. Okay. And then path args out dot write text. So we create a file in the path. And we write to it JSON dumps model to save, ensure ASCII, false indent to encoding UTF-8, and then we print saved model to args out. Else if we instead type in encode, then we want to load the model. JSON.loads path to the args model. We read the text, and text we set to args.text, whatever that might be, if it's an input or like a file. And as long as if args.text is not none, or no, args text, we set it to args.text as long as args.text is not none, otherwise we set it as the file. Okay, that makes sense. And then we read that text. And we set the local variable IDs to encode with model function, and we pass along the model and the text. And then we print the encoded information, basically. Otherwise, if we type in the code, then we do the exact same thing here to load the model. And IDs set to a list. And we make sure it's an integer. Or should I say we convert it to an integer. Well, no, we split the IDs list. By each comma. And we convert it to an integer. But I'm a bit confused why this if x.strip. I mean, does that mean we do it all the time? Like each iteration, do we strip it? Or do we only do this if we strip? I should probably ask about that as well, just to make sure I actually get it. Here we are. Break this down for me. I'm gonna go grab some more water. Be right back. And I'm back. Sacred water. Nice. Okay, so here's the line piece by piece. IDs, arcs ID, single string from the client. Yes. Split. Splits the commas. And it returns a list, I think. This is a list here, so I suppose it... Let's just say it returns a list. And... Why do we have these empty stuff here though? That's a bit confusing. For x in loop over those chunks. If x strip keep only chunks that aren't empty. / white space. If x strips remove spaces, its result is empty, falsy. The item is skipped. Okay. I suppose because we have this if statement at the end, that means like if this, then do whatever comes next instead of this here. But since we don't have anything here, then it just skips it, maybe? After this filter, okay, int x converts each chunk to an integer. Okay. ID results, which written this way, handles extra spaces, ignores trailing commas and double commas. Keeps the coding compact. Gotchas, non-integers, raise value. Okay. And I don't really care about that. And then we set the text to decode with model, and we support the IDs and the model. And here we have to be careful to supply the same model as the one that encoded it. Otherwise we'd get very different results, is my guess. And then we print the text. And that's all we do after decoding it. And then here's only the main function calling. Oh wow. This was a lot of new information. I should probably get like 5 different exercises, like between this exercise 8 and exercise 7, just to like prepare me for all the unknowns that we encountered in this exercise 8, but we muddled through anyways by going through it like slowly but carefully, step by step. And I'm honestly kind of confident in saying that I understand it all. Maybe not like on a granular level, but like on a holistic level. I understand it, I think. And all the unknowns that may linger or stuff like that I've forgotten will probably get cleared up later. I mean, exercise 9 is supposed to be something similar to this, but with with a twist to it. So yeah. The only thing left is actually to run it, since we haven't done that yet. And I suppose just doing it in the terminal here is sufficient. So Python tiny bpe.py. The following arguments are required. Why can't I run it like this? Let's move back to here. We have from your project root sandbox. Oh, here it says to make a PowerShell. Okay, let's do that then. So we create a tiny bpe run. Yes, one I think is for PowerShell. Or perhaps not. Perhaps the best way is to simply wait, how do I open in File Explorer? So here instead, and open in Terminal. And from here then do Python tiny bpe .py. No. If I were to copy and if you paste this text into your shell, it may result in unexpected execution of commands. No. I suppose it's easier to simply do it like I originally intended. bpe run and .ps. I think ps1 is for PowerShell. Well, I got the icon here, so I think that's correct. Do we install the recommended PowerShell? Show recommendations. I mean, it's from Microsoft, so yeah, that's probably a good idea. And can simply copy this text here like that. And this is creating a string in my guesstimation. And then we forward it to out file, encoding toy.txt, which is a new text file. We create a text file in here is my guess. And I don't know what's the differences between like PowerShell and Python in here, but this might be because I installed PowerShell. Who cares? For now, let's move on. So when I run this script, then it will probably create a new text file called toy.txt, and then it will train it by running python blah 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 train, and we pass along the text and we set the vocab size to 100, we lower it, we normalize it, and we set the output to tinybp.model.json. And then we encode it. No, do we encode something else? Oh, this is the training material, obviously. And then these are the other text we like to encode later, 2 IDs. And then we decode it. Paste the IDs from the previous command. No, I think I'm getting this mixed up. It's much simpler to simply create a new text file, call it toy.txt, and delete a new file, toy.txt, and then simply paste this text in here, and then we should be able to simply run this straight from the terminal here. And it worked. And we got a model here. So this is our model. And the vocabulary. With the most common being this one here. Which is a pretty obvious since we have like 5 of them, or 4 of them, and maybe 5 with the S added on. No, 4 probably. And then calf becomes the next most common one. And then we have the various merges. Okay, and here is the metadata for the space, character, normalizing, lowering, and stuff like that. And I might as well delete this one, otherwise I might confuse myself with its purpose. And could encode some text like this here. And we get these IDs. And if you want to decode it, then we pass along it with the model, and the IDs 0, 4 and 12. And like that. Cafe cats, it prints out then. Neat. And to make sure this works as well, let's do cafes as well. And 0, 0, 12. Cafes. Nice. And cafe is then the first in the vocab list, and then S should be the 12th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is confusing me quite a bit actually. I mean, is period actually more common than the SS? S. No, it's not. It's the same. It's equally common. Then if I run this again, and again, and again, and again, the decoding is actually working. I was worried like there was a chance that the S would be replaced with a period, but no. I'm a bit curious about what this will print, because this is a different value number or different IDs. And we get an error, list index out of range, because we don't have 32 positions probably. That's the reason. This is simply garbage text. I don't know, maybe if we did like 14 instead, then we'd get cafes and yeah. Okay. But this is honestly pretty damn awesome, I should say. We have our training data here, which is basically nothing, but it's something. And then we have some test text we encoded and decoded. If you hit an out of vocab character on encode, just retrain with a bigger or more representative corpus. The corpus was the language list or whatever, or the larger vocab size. We did have a readme here, which is very, very long. I want to try training it on that, but let's try it. Just for the fun of it. And since the name is readme, saved model, and now we should be able to go to the model and I wonder if the vocabulary is too limited in size, if that's why we get like very few actual words. Let's try doing it again, but with a vocab size of I have no idea like what's reasonable. Let's try 500 maybe. It might still be too small though, I don't know. And here we have now more actual words, so that's kind of interesting that I actually got that correctly. But I've like figured out the problem on what was going on. And we have a lot of different merges here. A lot of them. So now that I've trained this on this text here, I should be able to like input a text. Let's say the rock gazed at the starry sky and raptured. I have no idea if like I intentionally put starry and raptured in here. I have no idea if these words actually exist, and it will be interesting to see if we get like an if we get an error from this, because it's a pretty big chance that we get something that something goes wrong with these words. But no, that seems to be working. And then we decode it. Should be able to copy this here. And then you simply press enter. Unrecognized arguments. Is that due to the spaces? It might be. Thought it would work with the spaces, but maybe not. Look at that, it actually worked. Wait, I feel like obliged to search for story, no result, and raptured, no result. So those words actually don't exist, but the tokens for them do, I guess. That's really interesting that it worked. Really, really interesting. It's a bit annoying that I can't simply copy and paste the IDs from here, but whatever. It worked. It actually worked. After all this time, all this work. But just to keep it consistent with the instructions, I'm gonna retrain it on the toy text. And now we have a much smaller model here. Okay. We also have the minimal tests here, but I can feel my voice giving out on me, so we might do this in the beginning of the next stream, perhaps. Or we might skip it. I mean, we already tested it and everything, but it feels like I'm missing out if I skip it for some reason. So yeah, we might do it on the beginning of next stream, but then I would want to move on to the next exercise. And yeah. I'm really happy that this is actually working. It's not much, but it's pretty cool. Pretty cool in my opinion. Anyways, thank you so much for watching. Please like and comment and subscribe. I appreciate it. And I see you in the next one. Bye bye.